Hi, everybody. My name's Andres. I'm here with Yvonne, who is a part of the software team. And today we're going to be talking about the accelerometer source code.
Hi, Andres. Thank you for having me here.
Thank you for being here. So, Yvonne, would you be able to give us a brief code overview?
Yes, for sure. So the sketch we'll be talking about today is the accelerometer basic example. And this is inside the folder of Module 5 accelerometer sensor. And this is all inside the GLE 2023 folder. And for this sketch, we will have a simple loop to measure and print acceleration in the X, Y, and Z axes. And the acceleration will be in G's, and it will be printed once every tenth of a second. To give a little bit of a background, G's are a unit describing the acceleration an object experiences, and it is relative to the acceleration due to Earth's gravity at the surface.
And for anybody watching, feel free to open up the code and follow along as we go. So next, we're going to be talking about library inclusion. So Yvonne, which libraries will we be using for the sketch?
We will be using three libraries for the MPU 6000, and the first one is the MPU 6000 library, and also we have the Arduino and GLE sensor libraries, and we only need to explicitly include the MPU 6000 library because the other two libraries are already included, and so we don't need to add them separately.
And now that we have those libraries included, we can move on to initializing our objects. So which objects will we be initializing for this sketch?
For this sketch, we will be initializing the accelerometer sensor object. And to do this, we will write the sensor type and the sensor name and fill in the two arguments. So here we have the type of MPU 6000 and the sensor name is accelerometer. And for the first argument, which is the unique sensor ID, we set that to 1. And the second argument, which is the debug mode, we'll have it turned off, so we set it to false.
Perfect. And now that we have that object initialized, we can move on to setting up the sensor. So how would we go about setting up the accelerometer?
Yeah, so to set up the accelerometer, we would do that in the setup function, which is only run once, which is different from the loop function that is ran repeatedly. And so in our setup function, run once, we will start the accelerometer by calling the accelerometer.begin function. And after that, we will begin the serial communications channel and set the range of the accelerometer to 2Gs.
Perfect. And now that we have the setup function completed, we can move on to the loop function. So the loop function is where we include code that will be executed repeatedly.
Yeah, so in the loop function, we will first read the acceleration, measure along all three XYZ axes using the accelerometer.getSample function. And this function will first read in the raw acceleration and then convert the readings to G's. And these readings are stored in the ACC variable.
And after reading the acceleration, we next want to print the acceleration. So how would we go about doing that?
Yeah, so we will print the acceleration in G's to the serial output for all three axes. And so here we can see that it is printed out for the X, and then the Y, and then the Z. And then we will wait for a tenth of a second before printing again.
And lastly, we want to talk about calibration. So would you be able to talk about that, Yvonne?
Yeah, of course. So the MPU 6000 comes with an initial calibration to plus or minus 3%. And in the 2G scale mode, this means that it is plus or minus 0.06 Gs of accuracy. And for what we're doing here, we won't require a higher level of accuracy.
And for future missions to the moon, we intend to add additional calibration. So thank you so much, Yvonne, for being here. I've definitely learned a lot about the accelerometer, and I hope everyone here has as well.
Yeah, thank you, Andres.